I was going to talk about a guy that got bored, but then he had an idea. And we're going to talk about a guy named Mr. Boone. Not Daniel Boone, not Benson Boone. Okay, we're talking about Gary Boone. Here he is. So Gary Boone, and he was working at Texas Instruments. We're talking the 1960s, 1970s, and computers, calculators, all these technology with electronics were starting to come out. And we had already gone through where vacuum tubes shrunk to transistors, then transistors shrunk to ICs, or the integrated circuits, so you could have one chip with lots of transistors inside. So electronics were shrinking. It was an exciting time. Well, Gary Boone was working at Texas Instruments, and his job was to work on the chip design. And basically, companies that had things like calculators that they wanted made, they needed special chips. And I'm talking about, these electronic pieces designed for the different computing components. And so Gary's job was to design and create these chips. So calculators kind of like this one, where you got it. Now that might look like kind of a big calculator to you, but at the time, that was incredibly small, a computer that could be so small. And so inside, there were several chips. Usually, Gary would get like a request for 4 to 6 different kinds of chips he would have to design. And the thing was, this company wanted some, this company wanted some, and all these companies wanted their special collection of chips. And so Gary's job was to fly around to these different countries. That might sound really exciting, but it got old to Gary. He went to Italy, Germany, Japan, and met with them. They told him, we want this and this and this. And then he had to go back and design it, and he'd do it all over again. And he started missing his family. He started getting kind of bored. It was like the same thing over and over again. And as he was thinking about this, he started thinking, you know what, everybody, all these companies, they want their own custom chips, 4 to 6 chips for all the different things. You have the processing, the memory, RAM and ROM. And as he started to look at the different company requests, he noticed they all really were requiring the same parameters. There were a couple little differences, but overall, it was the same thing. I mean, they were all for calculators. And so he had this idea. What if since I know what all the companies that have given requests need, what if we designed a chip that we put all of these parameters into? Like, we made a chip that could do all of it. And we also put in each of the pieces that it would, instead of 4 to 6 chips, what if we did 1? Okay, now that might sound a little bit like the microprocessor, but it's actually different. And in fact, this is at the same time the microprocessor is being invented somewhere else. But his idea was, okay, so he starts looking at the list of things. So they need a processor chip. Okay, so it's the computing part. We need memory. And there's RAM and there's ROM. And so the RAM is random access memory. And this is basically the memory that is fast and short term. So it's what the computer will have basically for working memory. It can do stuff and it'll be gone, do stuff and it'll be gone. Then there's ROM memory, which is the read-only memory. And this is like permanent. It's inside. You're not going to delete it and change it. It's inside. Both of those kinds of memories, RAM and ROM, okay? And then inputs and outputs. So that's basically, think of a calculator. If you have a calculator and you're having input, maybe it's pushing the buttons. You need to have a special chip that can process that. And what about output? Like if it has a little display, outputting data to that display, lighting up those numbers, okay? So he's got to design a chip that can integrate all of that into it. It's going to be an integrated circuit, but an extreme one. Well, he works with another engineer, and this is the patent diagram that they put together. And they were able, it's kind of hard to read, but on this one chip, they were able to put the different memory, the input-output system, the processing system, all on the same chip. And since they knew the specific things that this chip was going to need to do, they could cut out a lot of the fluff. Whereas like if you have a microprocessor that you're going to use for a computer, you may not even know what kind of programs it's going to have to take on. So you want it like really powerful, be able to do all these versatile things. In this case, it's more, we know exactly what this chip needs to be able to do, so they can refine it to designing it just for these specific tasks, okay? So they get this patent, and here comes the first microcontroller chip from Texas Instruments. And it's the TMS 1802, and it was in September of 1971, actually 2 months before Intel would announce the first microprocessor. So this is the microcontroller, and it's for, specifically, they called it the calculator integrated circuit. So it's an integrated circuit, but it had all this stuff right inside of it. And because they took things like, remember the RAM and the ROM, they put that right into the same chip, the efficiency was 40 to 50 times higher than previous calculator systems they had done. And so one of the first calculators that used this was the Sinclair Executive. Look how small that is. And if you compare it to that one I showed you earlier, that's a lot smaller. They were able to shrink it down. This is a picture they put out to kind of help people understand. So if you look at the top, 1969, you have all those chips. Then 1970, there's the 4 chips that they needed for the calculator. And then finally, in 71, this one microcontroller. And then they would work on that more, and they would come out in 1974 with a new refined microcontroller chip called the TMS 1000. And this one's kind of considered to be the real first, successful microcontroller that hit the market and was sold in large volumes. But it's hard to even fathom how much this was going to be used, because it wasn't just calculators. It turns out there's so many things that started to use it. So if you had some little computer in an electronic, even in for cars, for homes, like your microwave, a little microcontroller that the exact tasks or functions it needs to do, and so you can design a chip that's just for those things, and you can cut out a lot of the extra stuff. And so that's what they were able to do. And one of the things that would come out, and some of us oldies may recognize this. So this, in 1978, the Speak and Spell. And this was released by Texas Instruments, and guess what it had inside? A microcontroller. And this thing, some of you guys are like, what is that? That's the iPad of other times, is what that is right there. But basically, to do this one, you could speak. Well, it could speak a word, and then you'd spell it. It would tell you if it was wrong or if you were right and all this stuff. They had to break new territory in the memory space. And they ended up having 2 memory sections, each that were 120 kilobits of space, which was a lot at the time. And for those of you who don't know what this is like, I'll just play this little thing here for you. That's, some of us are like, oh, whoa. That's the 80s one. Here's the 90s one. Oh, yeah. Anyway, but this was the first electronic toy, learning device toy with a microcontroller. But it kind of woke up the world to the kinds of things you could do with this. And we go to now today, and they're literally all over the world in all of these electronics where we need some special computing, but a certain function or a certain set of functions. And so microcontrollers would eventually go all around the world and change the world. So if you get bored, stop. Maybe you'll come up with a good idea. Thank you. Okay.